Hello guys, I wanted to make a quick video about parabolas. That seemed to be the thing today when I in class, that of all the conic sections actually was giving students some of the most trouble. So I wanted to make a video just clarifying a few things. And we're going to repeat some of what we talked about in class, but I wanted to draw just a really quick, very generic looking parabola, and I have a coordinate system here. And if I just draw like standard y equals x squared, like that's the very base parent function of a parabola. But let's say we're drawing some generic parabola, so we don't know necessarily how stretched out or squashed together it is, but that the vertex, meaning like the minimum or the maximum of the parabola, if it's an up and down parabola, a functional parabola, is at 0, 0. One of the branches, one of the sides goes up like that. It goes like this. It's in this U shape, right? And there's some important information here. We talked about this in class, but for every parabola, like we went over these real world examples of parabolas, and all of those were like seem to be very important. Where the focus was, they all had like satellite dishes had this little thing that was like centered in this weird spot, and then I told you that that weird spot was called a focus. And that focus was like inside the satellite dish or inside the parabola. And there's an important piece of information that we know about where the focus is with respect to the parabola. There's all sorts of properties. Basically, the property is this: if you have a point xy, why did that one go away? Hold on. If you have a point xy on the parabola, any point xy on that parabola, the distance from this focus to that point, we call that d1, that distance is exactly equal to another distance to some other thing called the directrix. The focus has a directrix also, which runs, if it's an up and down parabola, meaning it opens up or down, the directrix is horizontal. If the parabola opens left to right, the directrix is vertical. So this is like the geometric definition of a parabola. It's the set of all points such that the distance from a fixed point called the focus to a line called the directrix is equal, like they're equal distance. And for our purposes, if we're going to think about the vertex form of a parabola, which is what we're focusing on in our class in pre-calculus, this one here, where HK is the center, HK is the vertex of the parabola, the only things that we need here are A, H, and K, because X and Y are X and Y, so any point X and Y. So H and K is fairly straightforward. It's the vertex. Now, what about A? We talked before about how A can be thought of as like a vertical modifier. It's stretching out or compressing this parabola. And the relationship we have with the focus, how the focus plays into all this, is this very important piece of information here, which I think people are missing. This distance, the distance between the focus and the vertex, which is equal to the distance here between the vertex and the directrix. This distance we call it P. In class, I went through a big proof about how we have a relationship between A and P, and that relationship is that A is equal to 1 over 4P. I'm not going to go over that again because it would be a waste of time. But it's very important to know that if the distance from the if you're given something like the location of the focus and the location of the directrix, then the distance between those 2 points is equal to 2P. Okay, so just keep that in mind as we're working through some of these things. I also wanted to show you, I also wanted to show you this quick at Desmos. I don't know if it's going to pop up here. I'm going to click this link in presentation mode before. Let me just see what I can do here. Did that work? Yeah, hey look. Here's a little Desmos thing about Directrix and focus. So this black dot is the focus. I can move it around. Ooh, it's pretty slow. I can move this around, and you can see that as I move the focus around, the Directrix moves too, but like they stay in the same orientation unless I move the focus above the parabola, in which case everything flips. So the vertex is always directly between the focus and the Directrix. In fact, it's P away from the focus and it's P away from the Directrix. This is just in the case of a up and down parabola. Well, what if I was interested instead in a left and right parabola, like one that goes horizontally? Well, we can do the same thing here. Hold on. Oh, this is going nuts. Yikes, hold on. Here is a left and right parabola. We have just a different, I put a different focus in here. It does the same thing, okay? It's like we have the same relationship, we have left and right, but the letters kind of change around a little bit, and that's what I wanted to talk about. So let's go back into this presentation here. This is when we have an up and down parabola. So left and right has a different equation, and that's that x is equal to a times y minus k quantity squared plus h. So notice, very important here to notice that the k and the h switch places, and of course now we have x in terms of y instead of y in terms of x. But this a is the same, so we find that the same way is orientation as far as where the vertex is with respect to the focus and the Directrix is going to be exactly the same. It's just now the Directrix, as you saw in the Desmos thing, would be a vertical line, not a horizontal line. Okay, so just need to establish those things. Now let's look at a problem. This form here, this quadratic that's given to us, is not useful to us at all because it doesn't easily give us the information we need. So what we need to do is complete the square. We've done this a million times. So I'm gonna solve for y. We're gonna just get the y on one side, so I can say that 8y, if I add 8y to both sides, is equal to x squared plus 4x minus 4. Now this right side looks like a perfect square trinomial, but it's not. So what we need to do is figure out what we would have to add to it to make it a perfect square trinomial. And what that is 4. It's half of 4 squared. So we have to add 4. If we add a 4 to that side, it means we have to add 4 to the left side too. So then we have 8y plus 4 on the left is equal to x plus 2 quantity squared minus 4. And you see this is sort of coming together. That's a 4 right there, sorry. Now we're going to subtract 4 from both sides. And what we're going to get is 8y is equal to x plus 2 quantity squared minus 8. And now we're going to divide everything through by 8. And the final equation that we'll get in vertex form is that y is equal to 1/8 x plus 2 quantity squared minus 1, because we divided the 8 by the 8 and we got 1. So from this we can get a few things. We can get the vertex. The vertex, which is hk, is hk. Okay, so this is the vertex for this would be -2, because this was usually x minus h. Now it's plus 2, so that means that h must be -2 and -1. That's the vertex of this parabola. The focus, now let's before we do that, let's transfer that vertex to this graph. So -2, -1 right there. That's the vertex. Now this here is a vertical parabola, and this a value here is positive. Therefore this thing is going to go up. Like I'm going to BS sketch in what this parabola would look like. Okay, it's going to do something like this, right? It's going to go up this direction, which means we know that the Directrix is going to be somewhere in this area, and that the focus is going to be somewhere in this area. Now, where exactly that is depends on what P is, okay? And P we can find because, as we said in the previous slide, we have information about how to get P, and it's that P is equal to 1 over 4A. Okay, and A in this equation is 1/8. Okay, so P would be equal to 1 over 4 times 1/8. So P would equal 1 over 1/2 because 4/8 is 1/2. So P is equal to 2. Okay, now that's not the end of using P. But what that means is if we went from our vertex 2 up, that would be where the focus is. Okay, so we know the coordinates of the vertex is -2, -1, and then we would be able to find the coordinates of the vertex. And we also know since we go 2 up to get to the focus, we would go 2 down to get to the directrix line. So we would draw the directrix line in here at what would be y equals -3. I'm going to delete these other blue lines. Get rid of this stuff. Oops. Wait, there it goes. Okay. Now, the other piece of information that we didn't talk about in class is that P, if we know the value of this, the absolute value of 4P, which in this case would be 8, right? It's 4 times P. That's something pretty important. That's called it's called the primary focal chord length. It also has an older school name called the Lattice Rectum. But what it is if you go from the focus, if you go half of the primary focal length, so 8 over 2, if you go 4 from the focus in either direction, like this direction or this direction, you will get a point on the parabola. Meaning, if you go 4 over, that point right there and the point right here are on this parabola. That's called that's what you know because of the primary focal length. If I was then going to actually sketch this parabola in, like now I have a better guideline. It's going to do that, and then it kind of eventually, it's a pretty thick parabola, but it eventually starts to go up. So that would be a pretty accurate sketch right there, but we're not done because we also want to list where the focus was, the actual coordinates of the focus. Coordinates of the focus, which would be, in this case, because we are changing the y value to get to the focus, it'd be -2. So we would start with the vertex, which is -2, -1, but then we added 2 to the y value to get to where the focus was. So that means the focus was at -2, +1. Okay, for the directrix, let me get the red back. I don't know why I have this other color red. The directrix is a line, and the equation of that line, like it would change. Okay, we subtract 2 from the y value to get to what the y value of the directrix line would be. So from the -1, we subtract 2, we get -3. But you can just look right here, like this is -3. So this is the line y equals -3. That's what the directrix is. Okay, so that's how you would graph these. I'm going to do another one. This one here, you'll notice has the y term is being squared. So this is going to be a sideways parabola. You can tell right away that the process is still the same. We want to rearrange this to solve for x. So we'd say 12x is equal to y squared minus 6y plus 21. We have to complete the square, so 12x is equal to y squared minus 6y plus 21. We have to add 9 to the inside here to complete that square, which means we have to add 9 over here. Then we have 12x plus 9 is equal to y minus 3 quantity squared plus 21. Subtract 9 from both sides. We'll get that 12x is equal to y minus 3 quantity squared. What's 21 minus 9? 12. And then divide everything by 12. And we get that x is equal to 1/12 y minus 3 quantity squared, and then 12 divided by 12 is 1. So here we have the same task. We want the vertex. We want the focus, and we want the directrix. crucial to finding the focus in the directrix is to find P, and we can do that right away. P is equal to 1 over 4A. That's A, right? 1/12. So for this problem, this is equal to 1 over 4/12, because 4 times 1/12 is 4/12, which is equal to 12 over 4, which is equal to 3. And 4P is equal to 12. So let's keep this in mind, that the primary focal chord length, is 12. Half of that is 6. So we're going to be able to go 6 to the above and below the focus. Let's plot what we know first. We know that, this was the standard form. I'm going to draw it up here. The standard vertex form for a sideways parabola looks like this. Y minus k Conic squared plus h. So we're interested, of course, in hk. So for this one, it's hk, right? So the vertex is going to be 1, -3. So we'll plot 1, -3 right here. Now this is positive. Sideways parabolas by default will open to the right if they're positive. Okay, so this is going to do something like this. Okay, we'll get rid of that sketch later, which means the directrix needs to be over here. The focus is going to be over here somewhere. Let's figure out where that is. We know that P is 3. So I'll do this in orange or something. If I go 3 from the vertex 3 this way, I will get to the focus, which is right here. And if I go 3 this way from the vertex, I will get to the directrix line, which will be this line here. Okay. So I'm going to delete the blue lines now. So now that I have that, that's pretty much everything, right? I can now get in some detail. I can say, because of that primary focal chord length of 12, if I go 6 left and right from the focus, 1, 2, 3, 4, 5, 6, there's a point there. If I go 6 down, 1, 2, 3, 4, 5, 6 right there, that the parabola is going to go through those points. So I might as well just sketch in the parabola right now. It's going to do this. Okay, and I want to know the coordinates of the focus and the directrix. So the focus coordinates is going to be the coordinates of the focus, but I am going to add 3 to the x coordinate because it's moving this direction, right? So I'm going to add 3 to it. So that means that the coordinates of the focus would be 4, -3. Directrix line is 3 from this x value, 3 this way, and it's going to be x is equal to something. That something is -2. So x is equal to -2. And now we're done with that one. I'm going to pause the video now where I go take care of my cat because she's meowing at me. I don't know what's going on, so hold on. Alright, I'm back from taking care of my cat. Something you guys might not know about cats is that they're kind of stupid. So, I basically just faked walking downstairs. Like I walked downstairs to see what she wanted, but then I just turned around and went right back upstairs. And she's kind of fat, so she's too lazy to come back upstairs, so she'll probably leave me alone for a little while. Okay, here's another problem. This is one that seemed to be giving some people some trouble. So, given information about the parabola, like how do we find the equation for it? And I only have this graph over here for sketching purposes because it's going to help. Anytime we're given information, just sketch it and see what it's talking about. So I'm going to draw the focus at 5, -2. That's right here. And the directrix line is at x equals -1, which is a vertical line right here. Now, from the previous examples, we know that from this distance from here to here, ooh, that was a pretty bad little bracket thing, but that distance is going to be 2p, right? Because from the vertex, which is going to be right there, it's p. This distance right here is p, and this distance right here is p. So the total distance is 2p, which tells us everything we need to know about this. It tells us that the difference between this point here and this point here is 2p, so this is 5 and negative 2. So this x-coordinate of 5 to this x-coordinate of negative 1 is 2p. Well, the difference between 5 and negative 1 is 6, right? So that means 2p is equal to 6. I'm going to write that over here. 2p is equal to 6. So p is 3. Now that's like almost everything we need. To write the equation of this in vertex form, we know that a is 1 over 4p. So that means that a is 1 over 4 times 3. So a is 1/12. So a is going to be 1/12 for this. And now we only need to know the location of the vertex. All we need to write the equation of a parabola is a and hk, which is the vertex. So this point here is the vertex because it's halfway between the directrix and the focus. And if we take this x-coordinate and we go 3 over, the location of the vertex is going to be 5 minus 3 minus 2, which is 2, negative 2. So that is your hk, right? So to clarify, hk is 2, negative 2, and a is 1/12. Now, the default form of a sideways parabola, one that opens to the right, is x is equal to a times y minus k quantity squared plus h. So let's just write the equation. X is equal to a, which is 1/12, times y minus k, that's k, which is going to be, so this would be plus 2 quantity squared plus h, this is h, 2. That's it, we're done. Moving on to the next problem. These should be quick. This is the last one, actually. Again, we're going to just sketch what we know. Okay, 7, 3, which is 1, 2, 3, 4, 5, 6, 7, 3. And the focus is at 7, 5, so 7, 5 is right there, right? So we're given the vertex and the focus. Now, in every previous example, notice that the vertex and the focus are along the same line, right? They have like an axis. This axis is called actually the axis of symmetry. So because we have this vertex and this focus on the same line, that means that this is symmetrical about the axis that you can draw through here, meaning this has got to be an up and down parabola. Parabolas only have symmetry in one way. Okay, and the focus is like inside the parabola. So the parabola is going to look something like this, which means that Directrix, which we don't know about yet, is somewhere over here. Right? We don't know exactly where, somewhere in this area. So let's figure out where all this stuff is. And of course, the crucial information is how far is it from here to here, because that value is p. Okay, and p is going to equal, in this case, because we had the coordinates of this, which was 7, 5, and we have, dang it, we had the coordinates of that, what happened to my 7, 5, and we had the coordinates of this, which was 7, 3. The difference between the y-coordinates of the focus and the vertex is 2, so p is 2. If p is 2, that lets us do everything else, because we know that we don't actually care where the directrix is, right? To write this equation, we know that it would be 2 down from 3, so it would be at y is equal to 1. But that's not important for this, because p being 2 and knowing the vertex is all we need. We need, again, remember, we need a and we need hk to write the equation of this parabola. So a is equal to 1 over 4p. Again, we know p, it's 2. Therefore, a is equal to 1 over 8, because 4 times 2 is 8. Right? Okay, now we know hk because it's given to us right here. So the default form, the vertex form of a parabola that goes up and down is this. So then we're just going to finish this problem and presentation and video by writing the equation. Y is equal to a, which is 1/8, times x minus h, which is 7, y squared, plus k, which is 3. Done. Okay, these are, again, they're supposed to be quick. Draw this graph. It helps you figure stuff out. Understand what P is. Understand how P is related to A. Okay, it will help you with all these problems. And make sure you don't mess up that this is a vertical parabola, one that goes like this or like this. And x is equal to A times y minus k quantity squared, plus h is a horizontal parabola, one that goes like that or like that. Okay, that's it. I hope this was informative. Make sure to like and subscribe.